Okay, so in this video, we're going to be looking at a network of scholarly papers, and we're going to be understanding that network using some rudimentary text analysis. And again, so just to give some context here, let me share a screen. We started off first to illustrate this idea of scholarly networks using a BiblioShiny interactive app, and that was a little fragment of our code that you saw there. And then we generated a network using the bibliometrics package in R, and then we looked at that network some more using this package called Gephi. And you know, it generates kind of a cool network. But the real thing we did in Gephi was we got some measures of centrality and community membership that we can work with. So we've got these different communities. And so in this paper, we're going to take those communities and we're going to look at them a little bit more carefully. So it's back to R. We're working, again, I'm going to start by cleaning up my environment here. Okay. And I load these packages in, cable for making tables, my bibliometrics package. I don't think I'm even going to use that here. Let's try commenting that one out. Okay. The tidyverse and tidy text. And then for working with my graph data, I don't think I'm generating graphs here. Let's try commenting this out. If I run into a problem, I can reload these later on. So let's just try that. Okay, we have everything is in this data directory, and there are my nodes file. I've got 794 papers, and those 794 papers, they include an ID number that I don't care about, a label that I might care about, a title, this journal name, and then this all text field. And this is the one that we're going to be looking at most closely. We're going to be looking at all text, and then not so much weighted degree or degree, these different measures of centrality. But I'm going to look at, actually, what I'm going to do, let me add a couple lines of code here. And I'm going to do that. I'm going to pop this up into a separate window. And I'm going to pop this up into a separate window here. So now I've got just these two things. I've got my code window and my data window together. And let's just try to strip this thing down here to look at just the fields we're most concerned with. So I'm editing this, and the fields that I'm concerned with are, let's see, I'm concerned with all text, and I'm concerned with modularity class. And I am concerned with page rank. Okay, so we've got, at this point, we've got, I think that's all I'm going to be working with here. Again, I can fiddle with this, page rank, modularity class, and so forth. So let's strip this down, let's simplify this. And when I do that, okay, my all nodes field, now, whoops, because I misspelled that. Now all nodes and page rank, because page rank isn't called page rank, it's called page ranks, which it shouldn't be, but I'm going to stick with that. Actually, let's do this. And then we rename it. So little quick handy thing there. And I'm going to make sure that I've got this and replace it almost everywhere in my file, except in the first thing. Let's look at the next one. Replace, replace, and don't replace. Okay. All right. So I'm going to put these back into my main screen, return to the main window. And part of the reason why I really want to do that here is because, well, it's very handy to edit things and see your work in a full window. If you're not careful, you may end up editing multiple copies of the same window. So, and you want to avoid that. Okay, that's just an aside. So we have all of our nodes, the 794 nodes. We get rid of the unconnected papers, and we see, whoops, I need a degree up here as well to make this work. That was the one thing. Let's add that back in. We have 4 variables. And now we're going to group this by modularity class. And the group by command in R, it just allows us to look at one thing in our one subset of the data at a time in R. And so what we're doing is we're just counting the number of papers in each of these modules. And then we're going to drop the small modules when we do that. And when we do that, we're down, we lose 46 of the papers. So that's fine. We're just getting rid of the smaller communities. And when we look at those, we look at, and I'm not going to be concerned with the label, or am I? I do want label in there. Okay. So I keep on going back here, and let's do that. Okay, so we've got most nodes, 748 papers there, and we're going to take those, we're going to select 3 fields, we're going to group it by modularity rank, modularity class, and then we're just going to look at the top 3 papers, rank less than 4, in each of these modules to get a sense of these communities. And what we're doing here is, this is our first take on what on the structure of the field, in a sense. What are these different communities? And the answer is, well, modularity class 1 is these 3 papers. Well, we didn't even get the title of here, did we? So let's go back and let's get the title as well. My bad. My attempt to simplify, I have oversimplified the data a little bit. It's not TI. It is. Instead, it should be TI lowercase. All nodes is fixed. Most nodes is fixed. We select these, and again, what we want is, so here is modularity class 0, includes the top 3 papers, including top 3, including the based on the page rank in the overall network. Okay, that's not page rank within this community. That's page rank overall, and that's going to be fine for us here. So we've got a review paper on big data in comp social science and comp social science and humanities. We've got a technical paper on eigenpairs. It doesn't look all that useful to me. The second community looks much more sociological, and the third looks more kind of engineering and simulation based. And then we've got some applied papers. Now, that said, I don't think that this approach to looking at the structure of these scholarly communities, I don't think that this approach has told us that much. I don't know what's going on yet. So we're going to look, and by the way, you see I flipped back over into visual or WYSIWYG mode in my editor just because. All right. A second approach to looking at what computational social science is we're going to abandon this analytical approach that we've used for the time being, comparing these different areas, and just look at the overall area. And so for this, we're going to look at the all text field. We're going to take the all nodes, including the ones that we've dropped, and we're going to strip them out into a vector of words. And that vector of words includes the title, computational social science methodology, anyone, ? Followed by the abstract, this article reviews, etc., followed by etc., all the way through our fields, title, abstract, keywords, okay, for all the papers. There are 163,000 nearly papers here. When we get rid of words like A and V, we reduce this down to 107,000. Those are stop words. And the stop words, if we want to describe a single corpus, a single body of text, we can discard the stop words because they don't really tell us anything. Now we're going to collapse that long list of 107 to a series of counts. And let's look at the number of words, okay? And this is an order list, the most common words in the field. And we present that as a table using the cable tool for looking at HTML tables in R. And here's our list. And you see that computational, social, and science are 3 of the top 4 words here. But it's starting to give us a sense of what the field looks like: media, network, networks, model, and models. There are ways that we can combine those words. And AJ is going to be talking about text analysis in much more detail later in the week. And we'll talk about ways of combining, of stemming words then. Okay. But for our purposes, we can see these are the top words in the field. Okay. Now, what I want to do finally is I want to kind of compare these or combine the 2 approaches that we've seen in those first 2 takes. In the first take, we had this analytic approach looking at different scholarly communities. In the second, we looked at the language of the whole set of texts. Now here, we're going to compare the language of each of those communities. And the way we're going to do that is we're going to take we're going to get rid of the very small communities. So we're going to work with most nodes, and we're going to get rid of numbers because we want to focus on words. And now we have 154,000 words, okay? And we're going to present them 1 grams as opposed to bigrams or trigrams or 4 grams or whatever, is a 1-word string, a so-called bag of words. And, these single words that can be really powerful. Sometimes we may want to look at bigrams like wasn't me. If you're Shaggy, you might want to look at that. But bigrams or not me is different from me, obviously. But we're just we're keeping it real simple here. So our overall counts of the different words, again, this is going to be pretty similar to what we had before. We've got something that looks like that, the, of, and. These are our stop words, but we're not getting rid of the stop words here because we're going to be comparing different groups. And the proportion of words that are stop words, they actually may be informative. Words like and, for example, suggest complexity of speech, but that's kind of a separate thing that we may or may not get into. Okay, so we're going to get these counts of words for our different groups. And when we do that, now we've got the class, the word, and the count. And obviously, these counts are going to be a function both of the size of the class and the popularity of the word. We're going to combine this with the overall proportions. And then we're going to get rid of very rare words. And part of the reason we're getting rid of the real rare words is that when we do a bibliometric analysis, sometimes these very rare words will be neologisms introduced by a single author on a single occasion, and we want to have something kind of beyond that. So we're going to ignore the very rare words, and then we get the number of words per group here. And then we're going to combine all of these things. We've got modularity class, the word, the number of total words in a community, the number of, the number of gee whiz, one sec here. This is the number of words in a community refers to the number of times that this word appears in this community. The number of total words in a community refers to the number of total words in that this word appears in the whole body of text. And then this refers to the number of total words in a community. So total number of words in a community, and total number of words that this, the word "the" appears in this community. And I have messed that up a little bit, but what we're aiming at is an index of the relative proportion of words in a community to overall. That's TF, IDF, it's something like term frequency over individual document frequency. It's been a while since I've done this, evidently. And when we do that, when we study these proportions, we're going to get something that looks like this. And and then we're going to rank order by this column. So a modularity class presumably includes some papers by Winter Mason. That's the most common word there. Obviously, Mason is both a word and a common name. But also modularity class 4 includes creativity. It's distinguished by that news and punishment, papers by Daisy Schelling. Proper names haven't been filtered out here. And then we're going to do this kind of more systematically, combine this into a table. And for our 4 classes that we pulled out here, 4 modularity classes, we have the following. We've got one group of papers which includes terms like photos and Flickr and crowdfunding and Bitcoin and Eurovision. A group of papers having to do with dictionary and sentiment and personality and words. This is a group of papers largely about text analysis. Our aforementioned group, modularity class 4, which includes both the political term, the term used in political science, disenfranchisement, as well as terms from social psychology and sociology and so forth. And then we've got papers associated with communication and, again, politics. So it's not a great solution here, I think. Let me nit this. It's not a great solution. It's a solution. But it has taken us a little way towards understanding the structure of computational social science. Maybe a little way. This isn't knitting. And let's try again. There we go. All right. So I'm going to generate that report. We've got this as a set of tables. It's not ideal. I guess the question is, in this, we've seen both this idea of what computational social science is as a set of papers. We've attempted with moderate success, I think at best, at isolating a set of papers in computational social science. Maybe we could have done better at that step of pulling the references down, okay? And then we've examined the structure of the network linking those papers. And there are a few approaches to looking at that network. We've studied bibliometric couplings here. We've examined that network a little bit using Gephi, and that was, in a sense, that's a superfluous aspect of this process. We could have done all of this in R, but I chose to illustrate with Gephi because Gephi is going to give us some nice tools for visualizing larger networks especially. And then finally, we went back and we looked at text analysis to try to identify what those areas were and to come up with an analytic definition of what computational social science is. So I hope that, I hope you got something out of it. And if you're inclined, go ahead and fiddle with this network, fiddle with the code, and see if you can come up with an interpretation of these areas. Maybe work with others, or maybe redo the network or the scholarly network of a different area defined by a different concept, perhaps an institution, perhaps discipline, whatever, to explore how computational social science can give us, or rather the tools of computational social science can give us insight into the structure of scholarly communities. All right, I'm going to stop there. And thank you.